So in this video we are going to explain about backtracking, which is a design and analysis of algorithms, one of the paradigm. The main learning objective of this topic is what is backtracking method and how using backtracking method the computational problems, especially the constraints computational problems, are solved by using backtracking method. Before going to backtracking method, let us review what are the other algorithm design paradigms are available, and you might have known already some of the algorithm methods, and one is divide and conquer and greedy method, dynamic programming, and backtracking, branch and bound. So in this video session we are going to focus on backtracking method. So coming to this backtracking method, this is a general method, that is an algorithm design method or algorithm design paradigm for finding solutions to all or some of the constrained computational problems. So coming to this constrained computational problems, each problem will have or it consists of some of the constraints. Those constraints are of two forms, that is implicit constraint and another is explicit constraint. The implicit constraint is nothing but the problem itself consists of some of the conditions. Such kind of conditions are known as implicit constraint. And in the problem itself, there are some conditions which has to be satisfied by the solution. They are known as explicit constraint. Let us have one example to know exactly what is implicit and explicit constraint. Let us take the problem sum of subsets problem. So finding a subset of given set S is equal to S1 to Sn of n distinct positive integers. So in this problem we need to find out all subsets of set S whose sum is equal to given positive integer d. Here finding a subset of given set S, that is S equal to S1 to Sn, and this set S consists of n distinct positive integers. So this distinct positive integers is nothing but implicit constraint, because the set consists of only the distinct positive integers, not any other numbers. And coming to the second part of the problem, so here the problem is we need to find out the subsets and with the sum of that subsets are equal to this positive integer d. So whatever the solutions we provide for this problem, those solutions need to satisfy this condition, that is the sum is equal to d value. So that is comes under explicit constraint. So whatever the solutions they satisfy this explicit constraint, that is only treated as a optimal solution for this sum of subsets problem. So let us consider one small well-known example, that is maze game. By this we can illustrate what exactly the backtracking method. So in this maze game we need to solve that from room A to room B we need to find out the path, how we can reach room B starting from room A. So let us start room A, and there is only one way to go to room 2. But here in the room 2 there are two alternative paths are there to go to two different rooms, that is 1 and another one is 3. Suppose if we select from room 2 to room 1, here there is a dead end. We cannot find or we cannot reach the room B. So we need to come back to room 2, and again there is another path, that is from room 2 to room 3. So that is selected. Now again from room 3 to room 4 only one path is available, so that we choose obviously. And again at room 4 there are two ways are available, that is one is from 4 to 6, the another one is from 4 to 5. Suppose if we select from 4 to 6, again at 6 we have two different ways. One is from 6 to room 8. So at room 8, again it is a dead end and we won't reach room B. So we need to come back to room 6, and again there is another way from room 6 to room 7. So again here also it is a dead end. We won't reach room B. So what we need to do is again go back to room 6, again go back to room 4. So at room 4 we have only one way, that is from room 4 to room 5. Again there is one way from room 5 to room B. So that room B is reached here. The maze is solved. But here at different points, that is room 2 or room 4 or room 6, if there is no path to reach B, we have came back to some point and again we have tried how to reach this room B. So this is the main key idea or basic idea of backtracking method. So let us see some of the constraint computational problems, few examples which can be solved by using backtracking method. That is, one is n-queens problem, sum of subset problem, graph coloring problem, and Hamiltonian cycles problem. But in this video session, we are going to focus on n-queens problem, how to solve this n-queens problem by using backtracking method. First, let us see what is exactly the n-queens problem. The problem is, place n queens on an n by n chessboard so that no two of the queens are in the same row, column or diagonal. So in this way, we need to place the queens. Let us see first what are the explicit and implicit constraints or exist in this problem. So here the n value is implicit constraint. What kind of n value we choose here? The another implicit constraint is that chessboard, like what we are going to place the queens, it should be n cross n only. So these two comes under implicit constraints. Coming to the explicit constraint in this problem, the two queens when we are going to place in this chessboard, it should not be in the same row, or the two queens should not be in the same column, or the two queens, it should not be in the diagonal. So whatever the solution we provide here, the solution has to satisfy these three explicit constraints. For example, if n is equal to 1, then the solution is trivial. If n is equal to 2, there is no solution at all. And again, if you choose n is equal to 3, again there is no solution. This is the one reason why always n-queens problem starts from n is equal to 4. So this is the way we have n cross n, that is 4 cross 4 chessboard, and we need to place queen 1, 2, 3, 4 in this chessboard. So here we have two alternative solutions are provided, and both the solutions satisfy the condition that no two queens are in the same row, or no two queens are in the same column, or no two queens are in the same diagonal. So from this we can understand that any problem will have the alternative solutions, but all the solutions does not lead to a optimal solution. But here, whatever the two solutions we have got, these two solutions have satisfied the explicit constraint and also the implicit constraint, and then we can treat these two are the solutions for n-queens problem. The n value may be 8 or 16, so whatever it is, we can solve that n-queens problem by replacing 4 with 8 also. Let us see how to design an algorithm for n-queens problem. But in this video session, because it is the out of class activity, we are not going to discuss an algorithm in detail exactly how each and every step in this algorithm leads to solution. So just go through the algorithm for this n-queens problem here. And another important thing when we design an algorithm for using backtracking method, and always we use the algorithms are recursive. That you can observe here that n queens k minus 1 comma n. So the n queens algorithm is a recursive function. And here we are going for two different algorithms. One is n queens. The another algorithm is required for to place the queens which satisfy those three constraints. That is not in the same row, not in the same column, or not in the same diagonal. So this is about what exactly a backtracking method and how exactly the backtracking method is used to solve various constraint computational problems, and also what kind of constraints exist in each and every problem, and how to select a solution which satisfy this explicit constraints. And there is a small quiz is also included in this video session. This quiz is very useful for self-assessment what exactly we understood from the previous slides in this session. And the simple questions like how the three queens problem has what kind of solution, and how many solutions we get for four queens problem. And another simple question is what is the valid solution for 8 queens problem. So I conclude this video session. So what is backtracking, and how backtracking is used to solve constraint computational problems. So these are our learning objectives of this backtracking method. Thank you. ఇదంతా రాదా ఈ సౌండ్స్ అన్నీ?